Hello everyone, I'm Gabriella Neri.
And I am Trisha Ermino of grade 11 Einstein. We're here to discuss to you the continuity on a given interval.
So stay tuned!
Objectives. At the end of this video, the learners are expected to illustrate continuity of functions on an interval and determine whether the function is continuous over a given interval. Definition. A function f is said to be continuous on an interval if it is continuous at every point on the interval.
For example, take a look at this graph. In this interval C to A, we can see that there are no breaks or hollow points, so we can say that this graph is continuous. However, on this interval A to B, there is a hollow point on this graph, so this interval is discontinuous.
There are certain conditions for a function to be continuous, and these are the following.
So for our sample problems, given function is x over x minus 2, determine whether the function is continuous or discontinuous on each stated interval. So these are the intervals. First is negative infinity to 0 and including 0. This is 0 and this is through negative infinity. We can see that there are no breaks or hollow points or asymptotes that gets in the way, so therefore this interval is continuous. However, on this interval 0 up to positive infinity, we can see that there is an asymptote getting in the way to pass through the positive infinity. 0 is included, but because there is an asymptote, this is obviously discontinuous. In this interval, 0 to 2, this is an open interval, so it means that 0 and 2 is not included, but there are values that gets closer and closer to 2, but not hitting 2. So we can see that although it gets closer to 2, it's still continuous because there are no breaks or hollow points that gets in the way. So therefore, this is continuous.
So now let's try solving this given function f of x is equal to x over x minus 2 by substitution method. On the first interval, 0 up to and including 2, by direct substitution, so we will have 2 minus 2 over here, which is equivalent to 0. And we know that in rational functions, the denominator should not be 0 or else it will be undefined and the graph will be discontinuous. So here on the second interval, we have including 2 up to positive infinity. So once again, by direct substitution, 2 minus 2 is equal to 0. And just like what I've said earlier, rational functions can have a denominator which is 0. Now what we have is the first interval, which is discontinuous, the second interval, which is also discontinuous. So now let's take a look at the third interval, which is an open interval. So 2 up to positive infinity. Since this is an open interval, it means that values that are close to 2 but are not 2. So it's not 2 and 2 minus 2 is 0, so this is continuous because, yeah, open interval, values that are close to 2. But
Remember, all linear, quadratic, and polynomial functions are continuous everywhere. Also, all absolute value functions are continuous everywhere. Third, all rational functions are continuous everywhere on their respective domains. Lastly, there are two ways in determining whether the function is continuous over a given interval. First is by graphing, and second is by substituting values from the interval. So now we're finished discussing the lesson. Here is a short assessment to see if you have understood what we have discussed. Pause the video until you're done answering the quiz and proceed to see the answer.
So yes, guys, thank you for watching this video and I hope you learned something from us.
And if you want more of this quality content, make sure that you're subscribed to our channel and hit the notification bell. Peace!